under transformers, we are saying a transformer, the quick explanation, a transformer, this one, is an electrical device which changes low voltage to high voltage or vice versa. So this means that this transformer, number one, it is an electrical device. So this one uses what you call electricity for its operation. Now, the main essence of this transformer, you need to understand that it needs to change this low voltage to high voltage or high voltage to low voltage, depending on the usage of that transformer. Therefore, we need to look at the structure and operation of a transformer. So we will discuss on how a transformer operates. Now, for us to understand how a transformer operates, we need to bear in mind that we need to understand electricity, magnetism, and electromagnetic induction. So, for example, if this is our transformer, so this transformer now, we have this part and this part. So we assume that we have a number of things like that. So this is the primary coil, and this is the source, AC. Then we have DC here. Then we have the secondary coil. Then this is what you call now the iron core. So they use iron because iron is easily magnetized and easily demagnetized. So according to the operation of the transformer, a transformer operates under this principle, which is called the mutual induction. Now, this mutual induction, so let me use this part. The mutual induction. So under mutual induction, we are saying that mutual, we're talking about the relationship between two parts of a transformer. So these two parts, we understand that you have the primary coil part and the secondary coil part. Now, induction, it is talking about inducing one effect from this part to this part without direct contact. So for us to understand this one, we need to look at a magnet. A magnet has the north pole and the south pole. So this north pole, it will produce what you call the magnetic field lines. They will move in this way. So that's the direction. Remember that the magnetic field lines, they don't cross each other. So these magnetic field lines are the ones that are coming now to the secondary part, to the south part. So these magnetic field lines from a magnet has made this part to be called the magnetic field. The magnetic field is a region where a force is exerted or experienced. So if I put a magnetic material in this field, meaning that this magnetic material will become a magnet. This permanent magnet, it will induce its magnetic properties into this magnetic material via the magnetic field lines. So this same principle is the same principle which we are going to use when we're talking about the mutual induction in the transformer. Then apart from this part, we need to bring again the aspects of electricity. So on the aspects of electricity, we know if we have the current carrying conductor like that one, then this current carrying conductor is connected to the source of current like that. So when current is switched on here, then the current will be moving like this. So when this current carrying conductor receives electricity, this one now will become magnetized. When this one becomes magnetized, it means that it has become a magnet. And this magnet now will behave in this manner. It will also start producing what you call magnetic field lines in the concentric circles. So here we are going to have something like this in a concentric circles. So this part now, we have formed what you call magnetic field lines. If I place anything here, which is magnetic material, this one will become a magnet, because the magnetic properties in this magnet, in this case a wire, which we have just created, will induce its magnetic properties into a magnetic field, into a magnetic material, and this magnetic material will become a magnet. So this principle and this principle has helped us to understand the principle of the mutual induction inside a transformer. Alright, so away from this part, we know we can determine the direction of the magnetic field lines by using right hand grip rule. Then here, having this in mind, now we come here, you are going to discover that when this part, the primary coil, is connected to a source of AC, which is called alternating current. Now, alternating current will be produced maybe by generators. So, once this primary coil is connected to the source of current, and this AC current, alternating current, passes through the primary coil. The primary coil now will produce what you call alternating magnetic field lines. The alternating magnetic field lines will induce the alternating voltage in the secondary coil. Then this alternating voltage in the secondary coil, in turn, it will also produce now or induce what you call the current. Hence, the current here now will be transported by electrical cables, either overhead cables or underground cables. So what I'm saying is that when the wires which have made the primary coil here, so current comes into these wound wires. Then these wound wires, since current has passed through these wound wires, in this case we're going to imagine as a current carrying conductor. Then these will produce magnetic field lines like this. So these magnetic field lines now, they will start moving in this way. Alright, so upon moving in this way, means that they have carried now. So this is now what you call alternating magnetic field lines. So these alternating magnetic field lines now has induced now on the secondary coil the alternating voltage. So this alternating voltage, which has been induced here on the secondary coil, the alternating voltage again will induce the current in the secondary coil, and the current will be transported. So this is the operation of a transformer. So number one, I have said that number one, the primary coil must be connected to AC current. When the AC current passes through the primary coil in the wires here, then in the primary coil will produce alternating magnetic field lines. The alternating magnetic field lines produced by the primary coil will now induce alternating voltage in the secondary coil. The alternating voltage in the secondary coil will induce current in the same secondary coil. Hence, the mutual induction has been taking place. So, this is how a transformer operates. So, apart from the operation of a transformer, having explained that, you can talk about the next part, the types of transformers. So, types of transformers. Alright, so types of transformers, number one, we know that we have a step down and step up. So we have two types of transformers. We have a step down transformer and a step up transformer. So these transformers are allocated depending on the usage of the area, if it is domestic or industrial. So step down, I'll explain here, then here there will be the opposite. So step down transformer, number one, it looks like this, the structure looks like this. Since it is step down, so here we are going to have more number of tens, while here we have few number of tens. So primary coil, of course, then you have the secondary coil. So the reason why we say this one is a step down transformer, number one, a step down transformer is a type of a transformer which has more number of turns on the primary coil than on the secondary coil. So the number of turns is directly proportional to voltage or current. So since we have more number of turns on the primary coil, so here the voltage is high. So if the voltage is high, maybe the power rating will also be high. So if we reduce the number of turns here, then the voltage will be low and the power rating will also be low. So a step down transformer is a type of a transformer with more number of turns on the secondary coil and the more number of the number of turns on the primary coil. That one is called the step up transformer. Then the step down transformer is the opposite of this one. So the step down, now it has more number of turns on the primary coil than on the secondary coil. So these are two types of transformers which we normally talk about. So apart from this part now, let's look at equations. So if you know step down, step up is the opposite. So the equation, we know that, or the formula, so we have number of turns secondary over number of turns primary is equal to voltage secondary, voltage primary is equal to current primary, current secondary. So current is different from these two. Current starts with primary on top. So this part cannot be used at once. So you need to use either this pair or this pair or this pair. That is how we use. So S stands for secondary, P stands for primary. Let's look at one example. example before we talk about efficiency. So let's say a transformer has 200 turns on the secondary coil and 100 turns on the primary coil. Calculate the voltage on the rated voltage on the primary voltage on the primary coil. If the secondary coil has 240 volts, so we can also determine the either this transformer or this a step-up transformer or a step-down transformer. So for us to answer this one, we can correct our data. So a transformer has 200 turns on the secondary. So number of turns on the secondary are 200. The number of turns on the primary, we have 100. Voltage on the primary, we don't have. The voltage on the secondary, we have 240 volts. So for us to find the answer now, we'll say number of turns on the secondary, number of turns on the primary is equal to voltage on the secondary over voltage on the primary. That's the formula. Then we apply the information. So secondary, we have 200 volts. Then primary, we have 100. Then voltage, secondary, we have 240 over that. So you do some calculations, so expect to have 100 times 240 over 200 and that. So this by this here, this by this, we make DP the subject of the formula to get this one. So you can cancel 2, you can cancel 2. So 1 times 240 is 240. Then 2 into 240, 2 into here, 1, then there, you're going to get 2, then 0. So VP is equal to that. So our answer is 240 volts. So this implies to say, since the number of voltage, the value of voltage on the primary is less than the one on the secondary, this one was a step-down transformer. Reason because the voltage on the secondary core is lower than the voltage on the primary core, so it is a step-down transformer. Then the other part is look at the relationship between the number of turns between the primary and the secondary. Then if the values they are in the ratio 1 to 2, meaning that also the other part, the ratio will be in the 1 to 2. You just need to divide by 2. That will be the answer, especially in section A, where there is multiple choice in terms of calculations. Alright, so this is one example you can look at. Then the other part on transformers, we can look at efficiency. So efficiency, we know that efficiency is calculated in percentage. So efficiency tries to talk about how efficient a machine is out of 100%. How is it working? If a machine is working more than 80% plus, that machine is doing fine. But if it is below 50%, it means that that machine has a problem, or it is losing more energy in the form of heat energy as well as sound energy and other energies which can be converted, the useful energy we want, into other energy which we are not interested in. So efficiency, we know that efficiency is equal to power output over power input multiplied by 100%. So this is to say current voltage of primary coil over current voltage of secondary coil multiplied by 100%. In a transformer, the secondary coil is the output, then the primary coil is the input. Okay, so efficiency can also be calculated to say work output over work input times 100%. It depends with the values given. But on transformers, normally we talk about this one because we deal with power. Now, from here, we can also understand something like this. If this is a transformer given like this, sometimes they will not give you the values you're expecting to have, like voltage and current and number of turns. Maybe, let's say, if you've been given 100 watts, they'll give you power and 65 volts. Then here, we'll give you 130 volts, then current. So if they ask to find this value, the value of current on the secondary coil, meaning that for us to come up with this part, we can use this formula of power is equal to voltage times current, where we need to convert this power into current because we have voltage here. So this one here, it's like saying 100 watts is equal to 65 volts then I. So the value of current we are going to calculate here now can be used to use this formula. Voltage secondary over voltage primary is equal to current primary over current secondary. You can use that one. Or apart from that, we can use Ohm's law. Ohm's law can come in here, where we will say now current is equal to voltage over resistance. Now that one will require you to find the resistance, then that answer you use voltage to find the other one. So this one will be more fast than that one, but either way the answer will come out. If you don't have resistance, remember that resistance is equal to voltage over current. So what you can do if you want, you can say current. You don't want to calculate resistance. If you don't want to calculate resistance, since this one is equal to this one, you just say okay, voltage over current. Where if you calculate, if you simplify this one, you can have current is equal to VI over V. So it's about understanding the relationships with what you have been given and what you are dealing with. So this one, I've just done my mathematics whereby division, you interchange here, this one goes up, this one comes down, then you put the multiplication sign, then this times this one over this one. So either way the answer will come out. But it's not always to say in an exam they'll ask you to calculate. Sometimes they will only ask you to resolve. So how do you resolve? You need to understand that when the number of turns on the secondary coil are more than on the primary coil, if you connect a lamp to that type, you find that the brightness of the lamp will be high compared to when the number of turns are more on the primary than on the secondary, because when that happens, you're going to have a step-down transformer. Hence, the amount of current or voltage being produced will be less than the one which we had before we interchanged the number of turns. So that also can be part of the reasoning. Then, the transformer sometimes will be represented by this symbol. So this is the symbol normally they use to represent the transformer. So basically, this is the quickest video which can help you to understand on transformers. So having this knowledge in mind now, you can apply the same principle, which is in form of questions in the past papers and in other books. So thank you